What's up? How you doing? I'm Hamish. A lot of people like to call me 25 bacteria diners, now river soldier, now river diners. Let's get started. No waste of time. You FaceTime before you do anything. Make sure you subscribe right here, under here, in the link below. Follow me on Instagram, social media, so we can get in touch as a family. You know what I'm saying? So now let's get to the question. Maximum value feasible region objective function. So this is more of the linear programming mathematics. So now they give you what is problem, and then you have to extract the information, and now you have to create the algebraical inequality mathematical expression. Now let's go. So they say here, Mary babysit for $4 per hour. Oh, so now we don't know how many hours Mary is gonna babysit. Means if it's $4 per hour, so let's say he babysit for 8 hours, it's gonna be 8 times 4. So we don't know, means it could be 4 times, let's say x. X is number of hours, which is assumed. She also works as a tutor, but she pay per hour 7. Oh, so these we're gonna say number of hours that she's gonna babysit. And then for tutor, we're gonna say, let's call y. You know what I'm saying? So this is gonna be y, so y times 7. Y times 7. You know what I'm saying? But this is gonna be number of hours for babysit and number of hours for tutor. Because for 1 hour, 7, so we don't know how many hours. Okay, she only knows to work at works for. Oh, okay. So now let's make a table. There's a lot of ways you can do. You can just do straight away, or you can make a table. But I prefer a table because sometimes these things can get bigger. So if you don't have a table, they kind of get you confused. So me, I'm gonna say, let x represent number of hours. Let's go speed. Number of hours that Mary. Because for 1 hour is 4, so x times 4, whatever number of hours, she babysit. Mary babysit. She babysit. And y is going to represent number of hours. What you gonna do? Number of hours. That what she does? She tutor. She tutor. Okay, so now for that case, now let's make a table. So I'm gonna make a very good table here. I like the table, man. Most of the time, this is my table. Always create like this. So this is gonna be x, and this is gonna be y. We don't know number of hours. And here we're gonna put the other data. Let's see here. What she want? What she do? She allowed to work at for her for 13 hours. Okay. So this is gonna be 7. X, because if this is number of hours, what she does, she do what? What she does for face? Babysit. So this is gonna be babysit. 7 hours. So it's gonna be 7 times x, because for 1 hour, $4. Excuse me, $4. My apologies, $4. So we don't know how many number of hours. 4 times x means 4 times 2 hours, but they didn't tell us how many hours. Okay. So now for this one here. For y, what is y? Y, she's going to tutor for 7 hours. So here, let's say tutor. It's not going to make sense. So for that case now, what she's going to tutor? 7 hours. So now, we're going to say 7 hours here. So now, this is not going to make sense. So I'm going to say x. Number of hours she babysit. So here is going to be babysit. Number of hours babysit. And this is going to be for what? For tutor. So I don't need this one here. So I'm going to say 7y. Now what do they say to these people? They say she allowed to work at most. So I wrote for you here at most. If somebody say at most is like maximum. This is a maximum at most. If you come home late, at most 7, you have to be at home. 7 p.m. means not more than that. You know what I'm saying? So if it's at most, you use this sign here. I've given you the sign. When they say at least, you use this sign. At most means not more than, means that value or less. So that's at most. You know what I'm saying? If I say at most 7 people need, means either 7, or it can be 6, it can be 5. You know what I'm saying? You know what I'm saying? But I say at least 7 people, means it can be 7, 8, 9, whatever. So now, according to the question, they say at most. So at most, we use this value here. At most, or not more than or maximum, less or equal. So this is going to be less. Oh, let's use the color quick. Oh, let's use the color. So we say less or equal. At most what? She allowed to work at most. Okay, so for baby seat and for Tura together, must be at most what? I can't see now. Where is that? 13 hours. You know what I'm saying? Now, she says she want to make, at least $65. So she want to make at least $65. So now, she want to make $65. So this, let's call this is total. This is total. This is total here, man. This is total. So they say she just want to make $65. But how she's going to make? Oh, meaning she want to make $65. No, this is wrong. My apologies. This is wrong. This is wrong. How did I say? This is not number of hours. I'm wrong. This is the money, because now this guy, if he's gonna work 4 hours times, let's say, every hour is $4, times, let's say, 2 hours. This is gonna give us how much this person is gonna get. So this is about how much total. So this is, let's say, how we gonna say, okay, this is a money. Let's say money. This guy is gonna make. Because if I say 4 hours times, let's say 2 hours, means he's going to get $4 in 2 hours. Means he's going to give me $80 plus, let's say this $80. Now here, if every hours get 7 rand, let's say he worked for 3 hours, means it's going to be $7 times 3 is going to give me 21. And this is going to give us the total amount of money. So I cannot add this and get hours. I'm wrong. Because this is money. I don't know if it makes sense. Okay, I'll say that one more time. You know what I'm saying? This one here is $4. So $4, let's say you work for 3 hours, means it's going to be 3, which is going to give me $12. So what is $12, man? It's money. So money plus money, you must get money. I can add money and get 13 hours. No, that's not true. So this and this is going to give me, that's what here it says, she wants to make at least. What is at least? At least will represent here, at least by greater or equal. Means either, at least means from there or more. So her expectation, whatever she's going to do, since it's at least, is going to be greater or equal at least. That was done 65. Because this is money. It must be money also here. Total. But let's talk about hours here. 13 hours. So for this case, since I didn't give out any information for hours, so I'm going to say this is for hours now for the second one. So I'm going to say x plus y. X plus y. These together should not be more than 13. So you see, these are hours, these are money. So these together should not be more than 13. Now I'm saying, so I have the two inequality. But at most, what does at most represent? At most, less or equal. So here it's going to be less or equal. Oh, so I have a two inequality. So it's gone. So now you're going to have to write something. We don't have an objective function for this case, but I need to have a constraint, extra constraint. Okay, what does that mean, constraint? When I say constraint, like this guy, you don't expect whatever he's going to do, he's going to get less, negative. When you go to work, means you must get something. So whatever x will represent, x represent number of hours, means it must be either greater or equal to 0. Even y also, number of hours. Means this is called constraint must be greater or equal to 0, even y greater or equal to 0. Ended. So these are constraints. We need them. I'm saying maybe it must be, you must do some number of hours, means greater or equal to 0. And this, you can have a negative hours, and you cannot have it, you know what I'm saying, to babysit for you to earn something. So now what we're going to do now, we're going to draw a graph. Unfortunately for this case, we don't have objective function, so we only going to draw our graph, you know what I'm saying. So now drawing graph is very, very easy. So I'm going to draw my graph here. So first, before I draw graph, I have to find x-intercept and y-intercept. So getting x and y-intercept is very, very easy. So come here. Let's make a space here. Get x and y-intercept. Let's start with this one. So for x plus, so say for x plus 7y equals 65. So this is for x. For the phase constraint. For x plus 7y greater or equal to 65. And the second one, x plus y less or equal to 13. Now let's start. When x is intercept, we know y must be equal to 0. What that mean? When the graph cut at x, y is 0. Now y is 0, so it's going to be 4. Everything is going to be 0 times 7 is 0. For x equal to 65. So this is going to be 4x equal to, don't worry about this one, we just want to get the value of x, so ignore the inequality. Divide by 4, so this and this cancel, so x equals 65, divide by 4, 65, divide by 4, okay, 16.25, so this is going to give us x-intercept equals 16.25 and y equal to 0, so that's the x-intercept for this equation. Now we have to use the same equation to get y-intercept. Mean this, we get x-intercept, and the same equation we get y-intercept. We want a y-intercept, x equal to 0. So x0 means 0, so 7y equal to 65. Divided by, because it's going to be 4 times 0 is 0, so 7y equals 65. 7y equal to 65. Ignore the inequality. Divided by 7 divided by 7, so this and this cancels, so y 65 divided by 7. 9.3, let's put 9.3, so 9.29, so this let me say 9.29, okay, so we have the x-intercept and y-intercept for the top question. Now let's go for this for the bottom one, x and y-intercept. I mean these are x-intercept and y-intercept where the graph is going to come. Now we come for this one now. X-intercept, when x-intercept, y equal to 0. So I mean this is going to be 0. This is x equal to 13. So 13 and 0. Now we go for y-intercept. When y-intercept, x equal to 0. So x equal to 0, so y equal to 13. So 0, 13. So now we can draw a graph. It's very easy. So drawing the graph, okay. So write down the system of inequality. These are system of inequality. I mean this, and this. Now I'm saying these one. These are system inequality and this one. These are see one in this, and this, and this. Now let's draw the graph now because they say represent this in a draw graph. So drawing graph is very, very easy. So the space here, what I'm gonna do, okay. Okay, cool, how we gonna do? Okay, let me take my I'm thinking okay, so I can erase the one on top because I don't need it. Yes, of course I don't need it. I just want to draw the graph, so I can just erase this to have a space. Oh yes. Okay, I just have to draw a graph, that's all. Man. Go quick. What you gonna do? What you gonna do when I look for you? What you gonna do with the African tools? Okay, let's go. So now, here we go. Okay, now let's draw a graph quick. So now we draw a graph. Okay, so now what is x-intercept? For this one, x is going to cut at 16.25 and it's going to cut at 9 at y. Oh, so x is going to cut at 16. Okay, 16, let's say this is 5, 10, 15, let's say 16 somewhere here. This is a rough sketch, guys, okay? So 16.25, so this is going to be 16.25 and y equal to 0. Now y is 9.29, almost 10. So let's say this is 5, this is 10. Let's call this is 5, this is 10 here. So 9 is going to be somewhere here. You know what I'm saying? It's a rough sketch, okay? So 9 is going to be somewhere there. So this is going to be 0, so this is going to be 0.9.25. This is a rough sketch. So now this is, let's say this is 5, this is 10. So now the graph, and this is, let's say this is 5, this is 10, and this is 15. So now we can join the graph. Never mind, it's not drawn in scale, so I was better drawn when I was primary school. So 4x plus 7y. So you can say here this line is for 4x plus 7y greater or equal to 75. Greater or equal to 65. My apologies. Now we go for the second one. So for this, x equal 13, y equal 13. 13, maybe this 15 is going to be somewhere here, and if this 15 is going to be somewhere, let's say here, rough sketch, never mind. Yeah, okay, so now we're going to join. This is going to be 13, 13, so this is 13, and 0, and this is going to be 0, 13. So we can join this too. Okay, Okay, so this is for x plus y less equal to 13. So x plus y less equal to 13. So now this is a graph. So now first and foremost, find the point of intersection of the two, where they intersect. So find the point of intersection of the two. So how are we going to get point of intersection? Means you have to solve simultaneous of these two questions. So how are we going to do that? So I can just erase this because I don't need this anymore. Oh yeah, I don't need this anymore. Yes, I don't need this, okay. Okay, so we want to get a point of intersection first before you do anything. So you can solve simultaneously to get this point of intersection. Okay, so our question is x plus y less or equal to 13. Don't worry about less or equal, you can just say equal for now because we want to get a point of intersection. And then I can make maybe x subject, you know, say x equal to 13 minus y. And then after that, I'm going to take this equation and then I'll substitute in the second one. So this is 4, but instead of saying x, I'm going to say the value of x equals 13 minus y. So 13 minus y plus 7y equal to 65. Never mind about the inequality because we want to get a value of x, y. 4 times 13 is equal to 52. 4 times y, negative 4y. Y, this could be 7. Y equals 65. So now, negative 4 plus 7 is equal to 3. Y, and this is 52. Plus, because this is negative 4 plus 7 equals 3. And equals 65. This one go over. So 3y. 65 minus 52 equal to 13, I think so. 52, 65, yeah, 13. Divide by 3, divide by 3. So the value of x, 13 divided by 3. 13 divided by 3 is going to be 4.33. Okay, so 13 divided by 3, okay, and now we get 4.33. So y, 4.3. So here, where the intersect is not drawn in scale, never mind. So it's supposed to be like somewhere here. Because, you know what I'm saying? Because if this is 5, this 4.33 is going to be here. So x we have 4.33. Now we want to get the value of y. If I get this, the value of x, I'm going to come and take this. It's just a normal simultaneous. Take this and substitute in here to get the value of x, because y I have, no, I'm wrong, this is y, so it must be in here, excuse me, it must be 4.33, and then now I'm looking for the x. So I want to take this y and put it in here. So I'll say my x equal to 13 minus 4.33, 4.33 to get the value of x at the intersection. And why do I solve like this? Because this graph the intersect. So oh yes, so you can refer to my simultaneous videos just in case if you don't know how to do simultaneous. But if you have the other method also, you can do it as long as you get to the answer. So now I'm going to say 13 minus 4.33, and then this is going to give us 8.67. This is going to be 8.67. So the value of y equal to, value of x, excuse me, equal to 8.77. 8.67. So it's 8.67. Oh, so now we want to get the feasible region. Feasible region, so I don't need this one, I get all my planes. So now we want to get the feasible region. How we get feasible region? Feasible region. Okay, feasible region. Let's get the feasible region quick. How do we get the feasible region? I'm gonna have to take. Okay, so these are first line here. You see, these are first line. Let's say these are first line. So if this, let's say, let me start with this line. This. Take any point either on top or bottom. Any point. You know what I'm saying? But for the most case, the no feasible region is going to be either if it's not here, here, or there. Somewhere here. Now I'm saying, but I know it could be here. Most of cases, they always come. You cannot guarantee. Now let's go. Take either point here, below or under. For now, we start with this line. Let me take a point. Let's say either, it doesn't matter. Okay, I'm going to take a point here. Let's say 1 and 1. I mean, this point is below the line. So our coordinate, let me say x equal to 1 and y equal to 1. So I'll take 1 and 1, and then I'll take this coordinate and put in this line. So line say 4x plus 7y greater or equal to 65. What is x? X equal to 1. So it's going to be 4 times 1 equal to 4 plus 7. 7 times 1. Y equal to 1 equals 7. So we want to see if it's going to be greater or equal to 65. So this is 11. Is 11 greater or equal to 65? No, it's not true. So since it's not true, means you don't shade under. You shade above. But if it was true, I was going to shade here on this region where I've taken the coordinate. So since it's not, so it means we shade other way around. Means this is my line, so I'm going to shade here. See what I'm doing here? So this is right region, the opposite one. So make sure you take it like, you see this one I've taken like these coordinates is like actual. Don't take somewhere like here that you're not sure about the coordinate. Take a coordinate, you know this coordinate is going to be under the line or above the line. I don't want to mess here. Okay, I don't want to go farther because my intention I want to have like this possible. Okay, now we go. Another things, so if this is not means the opposite side must be, it is. But you can test, but don't waste a lot of time in exam. If you know this is not means the other one is gonna be easy. But let me just show you just in case if you want to say, how do you sure about it? Now, look edge. Okay, let's say you take 5 and what is this? This is 13, right? Let's say 5 and 20. So I know 5 and 20 means this x is 5 and this 20 is going to be somewhere here on top of this line. So I'm going to say let's take 5 and 20, and we know this must be true if that's the case. So I'm going to say 4x, 4 times 5 equal to 20 plus 7. 10 times y equal to 20. 7 times 20 equal to 140. This is going to be 160. 160 greater or equal to 65? Yes, it's true. That's why it's true. So that's why we shade there. You know what I'm saying? That's why if this one denied, don't worry about testing the other one. Just shade the other side. Now, so now we're done with that line. Now we want to go for other line. Okay, now let's go for the other line. What is the other line? The other line is this, which is what is x plus y, let's equal to 13. So now for that case, we're going to take either coordinate below, under. You know what I'm saying? Let me take a coordinate here because this is the coordinate under, or even above. It doesn't matter. Okay, let me take here 1 and 1. I don't like to take like a bigger number because it wastes your time in exam. So let me take a 1. X is going to be 1 plus y equal to 1. Is it less than 13? Yes, it's true. So for that case, for this line, we're going to shade under because it's true. It does accept. So for this line here, so I'm going to shade under. Look now, so it's going to be. So when you shade, make sure you do something which is something great, like something which makes sense. Okay, let me use the other color quick. I'm going to do let's say like this. Okay. But my line starts from here, right? Because I don't want to mess, okay. So now what you're going to have to look where do they intersect. The area where they intersect is here. Here is where they intersect, look. Like this one goes up and this one comes, because this is a line, like it comes down. So the place where they intersect, that's our feasible region. You know what I'm saying? And that's going to be our feasible region. So for this case, where do they intersect? Because here is like only red and there is only black. But here is where there's a black and red. This is where they intersect together. So our feasible region is going to be here, like this point, like this region here. Let me. I think you understand what I'm saying. Like this is only our feasible region. So this other stuff I don't need. So I can just say I don't need. This is okay. I can just say after. So it's good to use a pen. So I can say I don't need you. Okay, let me just say I'm going to do here, man. Okay, I can just redraw another one quick. I believe you understand what I'm saying. Okay. So our feasible region, that's where they intersect. So let's see. Okay, this is 8 0.67 and then 4.33. So these are feasible region here because they intersect both. You know what I'm saying? That's a feasible region because here is like a long red and there is like a long, but here is when both intersect. So the coordinate of here is what is this coordinate? So 0, 0 and 9.25. And here this coordinate to top is 0, 13. Okay, 0, 13. This is 0, 13. And this one, okay, so the other stuff I don't need them. So this is my feasible region here. You know what I'm saying? That's my feasible region. You know what I'm saying? So since I got my feasible region, now, so for this case, I need to have a feasible planes. So my feasible plane is this, and that. So my feasible plane, let me just, yeah, feasible plane here, feasible plane. So my feasible planes, the first one is 0, 9.25. The second feasible point is 0.13. And the third feasible point is 8.67 and 4.33. So these are my feasible points. So since I got my feasible points, so for this question they did not give us the objective function. But let's say they say we have objective function. Let's say our objective function is, let's say objective function have x, y, let's say 20, I'm just saying, let's say plus y, or let's say 3y. So we want to know which one is going to give us, let's say maximum. It could be profit or whatever the information you have. For this one now is about this guy, how many number of hours. So we want to see, so for this case, which function? Let's say salary function. Which one is going to give him more salary? You know what I'm saying? So I mean, which point is going to give him more salary? So this is the objective function. By objective function. So now let's see which is going to give him more salary. So we have to use this feasible point and put it in here and see which is going to give him more salary, which is going to give him less. So which coordinate we're going to check? So we start for the first one, F. So 0, 0. The first one is 0. And 9.25. So we're going to say here 20. What is x? X equal to 0 plus 3 times y. Y equal to 9.25. So plug in the calculator. This is going to be 0. Okay, this is going to be 75 to 7. So this is the amount that he's going to earn dollar. 27.75. Now we go for the second one. So this one be 0.13. So F 0 and 13. So we're gonna say put in a feasible function. For this case, you say salary, which one is gonna make more salary. So this is gonna be 0 plus 3 times 13. This is 0, 39 US dollar. So if this guy, he's gonna use this feasible, is gonna make more money compared to this. So by any means, this is not good deal. It's not good feasible points. This is better. Let's go for the last one. So last one. F, I think this could be more than that raise. 67, excuse me. 67 and then 4.33. So this equal to 20. What is the X? 8.67 plus 3. What is the Y? Y equals 4.33. Okay, so check my calculator quick and then I want to see which is going to give us more profit. So you take 20, 20, 20 bracket and then you see 8.67 and then plus 3 bracket 4.33. Okay, cool. So this is going to give us a lot of money, man. 186. 186.39. So this feasible region, feasible points is going to make this guy get a lot of money. You know what I'm saying? So this guy, for him to make more money for what he worked with tutor and for Mary, for Shaw. Come on, man. So Mary need to have X. What does X we say represent? X represent we say number of hours. So she needs to work for 8 hours 67. You know what I'm saying? And Y must be this for her to make such amount. So she needs to have X equal to 8.67 hours for, was it baby seat first? Yeah, the first one was baby seat. For babysitting, and she needs to have a 4.33 hours for her teaching or tutoring. for how to make this such amount. Listen, man, you face what you gonna do? What you gonna do when they come for you? We out. Subscribe here, man. You subscribe right there, okay? So we can keep in touch. If this video helpful, leave a comments right here, man. Don't be selfish, man. Peace. I'm out. Bye-bye.